In exercise 1 through 6, solve the equation algebraically, support your answer graphically, and identifying the extraneous solutions. This is what's called a rational equation. Rational, meaning not sane, means a variable unknown in the denominator. In this case, we have x minus 1 in the denominator, and here we have x in the denominator. So then the first thing we're going to look at is, are there any values of x that cannot be possible? Well, we cannot divide by 0 in math or in algebra. That operation is undefined. And so we know, because we have x is the denominator here, x cannot equal 0. And we know for this denominator, x cannot equal 1, because 1 minus 1 is 0. So if we are in the process of solving this equation to find any solutions that have either of these answers, we would call those extraneous solutions. Extraneous solutions meaning answers created in the process of solving the problem. So we're going to take a common denominator and clear out the fractions, and we can find a common denominator by multiplying denominators together. So what we're going to do is multiply these two denominators, x and x, quantity x minus 1, together. So we have the whole equation we're going to be multiplying by x times quantity x minus 1. And multiplying this all out, we're left with 3x times quantity x minus 1 over the denominator of x minus 1 plus 2x times quantity x minus 1 over the denominator of x equals 8 times x times quantity x minus 1. And we can start canceling things out. We have quantity x minus 1 over x minus 1 cancel out. X over x cancel out here. So writing down what we have left, we have 3x plus 2 times x, 2 times negative 1, so that would be plus 2x minus 2 equals 8x squared minus 8x. We will combine like terms here. 3x plus 2x equals 5x minus 2, 8x squared minus 8x. We are next going to move over to the other side of the equation, our 5x and our negative 2, so we do the opposite operation, minus 5x plus 2, and so we have cancellation here to equal 0. So we have 0 equals 8x squared, and negative 8x minus 5x is minus 13x, and we have plus 2. Now, we could try to factor. That would be the easiest thing to solve for x. But if we look at these numbers right here, what are going to be your factors of 8x? We'll have 2x and 4x maybe, and we'll have 2 and 1. But if we go ahead and work these out together, we would have minus minus, and we'll quickly find out that there is no way we can factor this function. So we're going to be left using the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I like to, when solving these types of problems, to put parentheses wherever we're putting in variables. So we put in negative, plus or minus, square root of, we have parentheses squared, minus 4, parentheses, parentheses, that'll be 4ac, all over 2 parentheses. And so plugging in values, we have the quadratic equation here in the standard form, where a is equal to 8, b is equal to negative 13, and c is equal to 2. So if we plug in negative 13 here and here, we'll plug in 8 here below and here, and then we'll plug in 2 for c here. So we have negative, 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 that's going to be positive, so x equals 13 plus or minus, and negative 13 squared is going to be 169, and 4 times 8 times 2 is 64, so we have 169 minus 64, we're going to have plus or minus square root of 105, and divide that by 2 times 8, which is 16. And so if we work this out and decimalize this, we're going to get numbers of approximately x equals, and I'm going to say approximately equals because it's irrational. We have x equal to 1.45 and 0.17. So those would be our solutions. We see that these solutions here do not match the extraneous ones we found earlier. Next, we're going to answer graphically, and to do that, what I like to do is take the original equation. There's a 4-step process that I like to solve by graphing, and we can solve any one variable equation that I can think of that is solvable by graphing. Equals 8. So here's our equation, and I like to use the original equation versus the quadratically derived equation, being that this equation is going to be less apt to have mistakes creep in that can mess us up. And so step number 1, solve one side of the equation for 0. To do that, if we subtract 8 from both sides of the equation, we have 3 over x minus 1 plus 2 over x minus 8 is equal to 0. That's step 1. Step 2 is change the 0 to either y or f of x. So I'm going to write this down as f of x equals 3 over x minus 1 plus 2 over x minus 8. That's step 2. Step 3 is graph the function. And so I've graphed the function, and go to this next slide, which I have over here with the equation. We can see that we have solutions here between 1 and 2, which will be 1.45, which we got here, and this here very close to the y-axis. We can see also, I hope, that we have vertical asymptotes at x equals 1, x cannot equal 1, and at x equals 0. So that's the process of solving a rational equation. Thanks.